Welcome back, fellow detectives, to another exciting episode of Data Detectives. In our previous video, we embarked on an EDA journey with the Stack Overflow Annual Developer Survey 2022. We have loaded the dataset, but before we continue, it's time to roll up our sleeves and tackle an essential step in any data analysis process, which is data cleaning and data pre-processing. So data cleaning and pre-processing are crucial because real-world data is often messy, containing errors, missing values, and outliers. These issues can compromise the accuracy and reliability of our analysis. By performing careful data cleaning, we can ensure that our results are based on high quality and trustworthy information. So now let's switch over to Jupyter Notebook and start our data cleaning and data pre-processing. Okay, so first of all, we will write some points. So already we have seen that our survey contains a wealth of information and we can limit our analysis. So we have already seen that our survey responses contain a wealth of information. Therefore, we are going to limit our analysis to some following areas. So let's see what are these areas. Okay, let's write a remark. That the survey responses contain a wealth of information. Okay, therefore we are going to limit our analysis to some following areas. Okay, first will be demographics. Okay, second will be distribution of skills, and third will be employment related information. Okay, so let's see first of all what was our survey raw df. Okay, this is the data set that we are available with. So what we are going to do is we will select some columns and we will fix our focus on those columns and their data analytics. Okay, so we have already selected some columns. So these are the selected columns that will be used for our analysis. So this is the selected column, and now check the length of the selected column by using the length function. So we have 42 columns. Initially we have approximately 79 columns. However, we have reduced the columns to 42 as per our need of analysis. Okay, now what we are going to do is we will extract the data set for only these rows. So how we are going to do this? Let's use survey df. We have given the name, and we will use survey raw df, and we will give only the selected columns as mentioned above, and we will create a copy. So these are the selected columns that will be used for our data analysis part. Okay, so let's run this, and now let's check the length of these selected columns, and these are 42 columns. So we have started with 78 or 79 columns, and now we have reduced our columns to 42 as per our need. Okay, so we will create our data set on these columns. So let's give a name, survey underscore df. So we will use survey underscore raw df, and we will use only selected columns. Okay, and we will create a copy. Okay, if we want to see the survey underscore df, so this is our now new data set. Okay, so let's see the data type to see the shape of our data set. Now we can see that it has approximately 73,000 rows and 42 columns. Okay, if we want to see the data types of every column from survey underscore df dot info, we can see the data types. From here we can observe that most of the data types of columns are object data type, except compensation total, which is a float data type, work experience, which is also a float data type, and the converted compensation yearly, which is also a float data type. Okay, so from this we can conclude that most columns have the data type object, either because they contain the values of different types, or either they contain empty values. Okay, so we are going to deal with empty values and manually adjust the data type for each column on case to case basis. So first of all, we are going to see survey underscore df es code column. Okay, this is the ES code column, which is also a column object data type, and let's see its value count. So from this, here we can observe that most of the categories that values most of the categories or values that are available in this column are integer type, except this which is less than 1 year, and except this which is more than 70 years. That's why the data type of this complete column is object data type. Therefore, what we are going to do is we will convert into a numeric data type. Similarly, if we see the data type of ES code pro, if we see the data type of ES code pro, here also we can see that most of the values are of integer data type. Therefore, we will convert these values into integer or numerical data type. So how we are going to convert is we will use the toNumeric function. Okay, so let's create a survey df, and we will use the column years code, and we will use pd dot toNumeric. It will convert the object data type to numeric. And what column we are going to select? We are going to select survey underscore df dot es code, and for the error values, it means for the non-integer values, it will give us the not a number value. It means it will assign all the non-integer values to nan value. Okay, on running this, we can see survey.d underscore df year es code dot value counts. Now all the categories are converted into integer data type. Okay, similarly we can convert for years code pro. We will copy and paste it, and we will convert in years code pro. Okay, and it is converted. Now we will do some basic statistics on these numerical columns. So let's see how we are going to do this. We will use the describe function, and it will give the basic statistics on our numeric values, or this will give us statistics on our numerical columns. So here we can see that the minimum coding years is 1 year and maximum is 50. Similarly, for years code pro, which is also 1 and maximum is 50, this is the compensation total. This is the web experience, which is of 0 years is minimum and 50 years of maximum, and this is the converted composition yearly. Okay, now let's see the gender column. Okay, let's see its value count. Here we can see that there are number of categories. Some categories has multiple values, that means men, women, and non-binary, genderqueer, or gender non-conforming. So we have to exclude these values and so that our analysis can be done in a simpler manner. Okay, so how we are going to do this? First of all, we will select the survey df function dataset, and we will select the gender column. Okay, now we will use the str function, and we will select only those values that contains the semicolon, and for the rest values it will give false. Okay, so this function will be true when there is a semicolon in the row, or it will give false for non-semicolon rows. Okay, now but we want only the columns with non-semicolon. So what we are going to do is we will use survey dot underscore df, and we will select only those columns where this is true. We want this to be true. So this condition can be true if we reverse it. Now what it will be, that it will give true for all the values which don't contain this semicolon. Okay, and for all the semicolon values it will give false. Okay, so for all the semicolon values we will assign not a null value or not a number value, and we will do in place equals to true to save our result. Okay, now if we see this column again, now we can see there is a clear picture of categories. That is, we have 64,000 men, 3,300 approximately women, and the rest of the categories. Okay, now let's shift our focus on other columns which are of object data type. So if we want to count, if we want to see the value counts of each object data type, what we are going to do is we will run a for loop. So for every column in survey underscore df dot columns, what we are going to print is we will print the survey underscore df column dot value counts. Okay, so it will give the value counts for each and every column of this data set. So some columns are clear and have lesser categories, like this, which is the main branch. Okay, it has less categories and the options are clear. However, if we see this employment category, if we see this employment column, we can see there are some values which contain multiple options. Okay, so for this purpose we are going to use a function which is the split multi-column function that we have created already. So this is our split multi-column function, and what this function will do is it will create a column for every option that is available. That is, it will create one column for employed, one column of full-time, and one column of student. Okay, similarly all the unique values that are available in these columns will be created, and for every row it will mark true or false whether that column or category is present inside that row or not. Okay, so how we are going to create this, that we are going to use this function which is split multi-column. What is going to do is it will first of all create a data frame result df with the column series as the first column. Okay, it will create the column series as the first column. Now now next is initialize. We have initialized an empty list options to store the unique options extracted from the values. Okay, next we will iterate over this column series for all the not none values, and we will split uh, the the columns or categories using this semicolon. Okay, so after splitting we will check whether this category, the new category, is present already in the columns in the options or not. If it is present, then it will not go into this loop in this if condition, and if it is not present in this options list, it will come and it will append this options list and assign false. Okay, and for other values it will assign true. Okay, let's run this function. It will be more clear when we run for a particular column. So let's run for the employment column. Okay, so employment underscore type underscore df equals to, we will use split multi-column function, and we will use which column, we will use survey underscore df dot employment. Okay, this is created. Now if we run this, we can see that for every category there is one column, and for every row it's the function has assigned true or false depending whether this category is present in those columns, in those rows or not. Okay, so now if you want to know which values or which column has the highest count, what we will going to do is we will use employment underscore type underscore totals, and we will use this data, and first of all we will sum it, and then next we will sort values in the descending order. Okay, so what we will do is we will assign ascending equals to false, and let's see employment totals. Okay, from this we have a clear picture now that the employee full-time has total number of respondents equals to 48,000, and for student full-time it is approximately 10,000, and so on. Okay, so this function, which is the split multi-column function, we are going to use in our analysis on every column when we are going to represent its visualization. Okay, so this video is concluded. So in this video we have done our complete data cleaning and data pre-processing. In the next video we are going to start our visualization, and we will answer some questions and find our insights. Thank you.